Hello everyone, I am Harsh Patel and today I am going to give you the demonstration of my project. So in this project, I first fine-tuned the Vision Transformer model and I deployed it on AWS Fargate service with application load balancing. Alright, let me tell you about the tech stack that I use for building this project. I use some Python libraries that includes PyTorch and transformers for fine-tuning my model, and I build my inference application with the help of FastAPI. Then the AWS services that I use includes ECS, Application Load Balancer, ECR, and CloudWatch for monitoring the logs. And for implementing my CI/CD, I utilized GitHub Actions. So here's the demo of my project. As I deployed my project on AWS Serverless, I could access it on the DNS address of the load balancer. Let me show you how it works. We have to upload an image, then we press classify pose and we get a result. The result is sitting, as we can see that the human in the image is sitting, and we also get a confidence score and the inference time.
Now let's perform the load test of our project. As you can see, currently only one task is running, and here are the CPU and memory utilization, which are very low right now. And here's the CloudWatch dashboard. You can see the parameters like request, availability, and latency. Now let's run the load test script that I wrote.
All right, so here are the results of our load test. As you can see, the successful requests here are 99 and the failed request is 1, and the total duration of our load test and the throughput and the average response time. And you can see the success rate here is 99%. And you can see the sudden spike in the CPU utilization and the memory utilization. And here's the CloudWatch dashboard. You can see the spike in requests and errors also, and the drop in availability. So here are the key features of my project. Firstly, I use the Vision Transformer model. The transformers treat an image as a sequence of patches like they do with words in a sentence. And transformers uses a self-attention mechanism to understand the relationship between patches. So they are generally considered to be perform better than traditional approaches like CNN. And I deployed my project on AWS Fargate serverless service, so I don't have to manage the underlying infrastructure and the pricing is pay per use. And I also utilize the AWS application load balancer. So the load could be equally balanced among my Fargate tasks. And I also enabled the AWS auto scaling. So if the CPU usage goes beyond 70%, the auto scaling add more tasks automatically. And here's the project structure that I use for building this project. All right, now let's talk about the Vision Transformer. So the Vision Transformer model that I use for building this project is Google's ViT-based transformer, and the dataset that I use for fine-tuning is human action recognition dataset that consists of 12 classes that includes calling, clapping, cycling, dancing, and many more. Now, let me tell you how the Vision Transformer works. It first takes an image as an input, then it splits that image into multiple patches. Then every patch is converted into a vector embedding, and a positional vector is attached to every patch. Then we add a special token that is called a classification token to our embeddings. Then we pass our embeddings through transformer encoder. The first stage is self-attention stage, where we try to find the relationship between every patch to every other patch in the image. Then the second stage is feed-forward network, where it processes the information from the attention mechanism and extracts non-linear relationship through activation function. And we have layer normalization as our third stage. It helps to keep the training stable so the model does not suffer from vanishing gradient problem. Then the classification token that we attached at the starting is passed through classification head linear layer. It maps the classification token to the classes of our dataset. It outputs the score for every class. Then we applies a softmax function to it to get the probabilities for every class. All right, now let's talk about the AWS services workflow. So when the internet user sends a request, it will hit the application load balancer. And our application load balancer, which resides in the public subnet of our virtual private cloud, will listen all the requests at port 80. Then our application load balancer will select a suitable target from the target group and routes all the traffic to our Fargate tasks, which reside in our ECS cluster of our private subnet. Here's the CI/CD workflow of my project. So when I push any changes to the GitHub, the CI job will trigger and it will build the Docker image and tag that image and it will push the Docker image to the Amazon ECR. Then my ECS Fargate service will pull the latest image from the ECR, and it will launches the serverless containers and run our Vision Transformer Inference API. Here are the future enhancements that I planned for my project. So the first is A/B testing. We could perform A/B testing before deploying our model into the production, and we could also implement batch inference so that multiple images could be processed simultaneously. And we could also monitor our project with the tools like Prometheus and Grafana.